So my project is simple. It's called PatchForge. Just like when we have in the house where we have a broken equipment and we try to like call an engineer to make those repairs. Sometimes we could do it ourselves. Sometimes we need those, and sometimes we either want to replace the entire object or we try to patch it, right? So you don't need to be an engineering experience or engineering knowledge or CAD design. So this tries to take the picture and generate that patch that you actually need. If it's a broken pipe and you need something to lock it, it's instead of waiting for your plumber, you could actually print out that patch with the agentic framework that has been developed. So just most times agentic frameworks are always like writing or voices or conversational, but it's trying to show the possibility of using this LLM agent in the physical world with physical objects. So currently it's a multi-agent system. We have different agents running from calibration down to segmentation with SAM2, down to measurement of the patch that needs to be printed, to thickness, down to mesh, because while we need thickness, we are trying to take a picture which is in 2D and we're trying to convert it to a 3D image. So we need to estimate the thickness, and down to like the mesh, which is actually the artifact that's needed for 3D printing, then validate it and also send to a printer. So currently, I'm actually using a Bamboo Lab A1 printer for this prototype. That's what I designed. It's generic. If you look at the code on GitHub, you can actually try and see if other SDKs API are available for other printers. So just to go quickly into it, so this is the UI PatchForge. So what you need first is to upload the broken part of the equipment, which in this case is just a cube with a broken edge. And because of reference, I give the AI some perspective. We actually use a coin label as well. So with that in mind, the next thing you need to do is to upload what the image looked like before. So in this case, we have the image, but in a ideal use case, you can check it from Amazon. You can check what the image looked like before it broke to give AI a reference of what is missing, the damaged part, and also to provide more context, you can also upload a video to show around the broken areas for you to get more context. Since, like I said, we're working in 3D. With that in place, now the AI agent starts work. We try to detect the damage done is currently going on. It's processing. You can see the life analysis, trying to get the segmentation, trying to get the depth, and trying to get the specification in terms of width, height, area, estimated thickness for that particular patch. So in this case, the rectangle we're trying to print. So you can see the segmentation is complete. The depth analysis is also going, and you can also see the agent interaction in place in terms of calibration, which is in like language that anyone can understand. In terms of it's giving you the confidential confidence intervals as well, the percentage of how confident it is. This is just to show what the process looks like. But you can also see a way to fine tune it, where if you have more pictures of the side of the image, you can actually specify it here in terms of thickness or chamfer to also like fine tune it. So with that in place, now we can generate the mesh, which is required to develop the final 3D print. 3D mesh, you can see it here in 3D. You can see it in 3D for that missing parts. This is the thickness. So you can either print it, download it, and send it via your printer UI, or you can use the API. You put your IP address, you put the access code for your printer, your specific printer number, and the specific filament, if it's PLA and the likes, to print. So thank you very much. I believe it's going to be very useful to women at home that needs to help with DUIs and repairs and everyone in general. Thank you. I'm looking forward to the meeting.